Hey y'all, I'm back with another Stats 101 lesson. My name is Alex. My disclaimer is that I'm not a statistician or a mathematician or anything. I'm just a grad student who likes stats. I figured today we could talk about dependent and independent variables. This is the basis of stats, and we need to understand this for research and testing. So we have the independent variable and the dependent variable. If you just look at the vocabulary, the dependent variable is dependent on the independent variable. The independent variable is independent and is not dependent on anything else. It exists by itself alone. But the independent variable typically affects the dependent variable. Again, the dependent variable is dependent on the independent variable. So, for example, let's say that your dependent variable is overall health. So my overall health is dependent on what? This could be such a variety of things, but the first things that come to my mind are your healthy eating habits, your workout habits, how active you are during the day. So each of those things would be an independent variable. How often you exercise, how well you eat, how active you are during the day. These are all independent variables that exist on their own. These are your habits that exist, and they will affect your overall health. Another example is, I think of health things a lot, I guess, but let's say that your dependent variable is weight loss. The independent variable could be physical activity. How high or low your physical activity is going to affect weight loss. Another thing is, let's say you're trying to test, your dependent variable is self-confidence. So then we're like, what are some independent variables that could affect someone's self-confidence? This could be your IV, your independent variables could be positive feedback, maybe healthy relationship with friends, maybe, a variety of things, but maybe you're testing to see how positive feedback from a teacher affects a student's self-confidence in that subject. So your DV, your dependent variable, would be the student's self-confidence, and the independent variable would be positive feedback coming from the professor or the teacher. So you would look at how that positive feedback affects the student's self-confidence. Another clear one is, let's say you're testing blood pressure. Blood pressure would be the dependent variable, which is dependent on what, right? So your dependent variable is blood pressure. That's going to be dependent on your salt intake. Your salt intake is going to be the independent variable. This exists on its own. You eat salt at some point during the day, and so you're going to look at how the amount of salt that you eat during the day affects the dependent variable of, it's like dependent variables are almost like the outcome variable. So how does the independent variable affect the outcome of the dependent variable? How does your salt intake affect the outcome of your blood pressure at a certain day or time? Another important thing to note is that there are typically confounding or extraneous variables. A confounding variable in the simplest sense is a variable in your equation that was not accounted for. Maybe it's a result of errors that you made or things you forgot while you were collecting data, or something you forgot to put in the measurement, you forgot to test for it, didn't think maybe it would have an effect. And we can typically reduce these errors through using random sampling or using within subject designs, which means that the first test would be, let's say there's 10 different participants, and then you take those 10 different participants, you test them on Monday, and then they come back on Friday. It's the same participants, you're testing them again to see the difference, how they tested on Monday and how they tested on Friday. That's a within subjects design. You're using the same subjects at different points to measure the same outcome or whatever you're trying to measure. So my point, what I'm trying to get to, is with confounding variables, typically it's something that you forgot to account for, but a good researcher, before they do their test, is going to try to rack their brain for any possible confounding variables, because you don't want to do all this great research and at the end be like, oh, I forgot to account for that though, so that really messes up my results. So an example of this that comes to my mind is, let's say you're trying to do any type of test where the dependent variable is maybe, let's say that like you're doing a test and you're trying to look at someone's heart rate in relationship with something else. So maybe you're looking at the relationship between stress and someone's heart rate. So maybe you have them come in and you're like, I want to take your heart rate and see if it correlates with how much stress you're experiencing at the moment, right? So stress in that sense could be the independent variable, and heart rate might be the dependent variable. Maybe you're trying to say that someone's heart rate increases due to the amount of stress that they're facing. But when you're testing heart rate and these types of things, you really have to look into what are some confounding variables, such as, did your participant just chug a jumbo Dunks coffee before they walked in? Because that's going to affect their heart rate. Maybe your participant has ADHD and is taking medication for their ADHD. That's a stimulant. That's going to boost someone's heart rate. So those could be confounding variables that were not accounted for. But hopefully, again, if you're a good researcher, go look at your study and think about the variables that could impact your study. Think outside the box, and doing that will really ensure the quality of your study. So hopefully that explains dependent variables, independent variables, and confounding variables a little bit. Put in the comments if you have any other questions, I guess. That's my video for today. Thanks, y'all.